Welcome to the Founders Tech Playbook Podcast, the place where you get real advice that you can use in your day-to-day startup journey and where we simplify complex technology concepts just for you.
In today's episode, we are going to unpack and simplify the HTTP protocol. Now, I'm going to use the RFC 9110 document that defines the overall architecture of the HTTP protocol, understand the common terminology and aspects of the protocol that are shared by all versions. So, who will find this episode useful? Well, HTTP forms the basis of architectures like REST and for API communication. So, really, anyone who is interested in this is going to benefit, but especially product managers and people in tech who are from non-tech backgrounds are going to find it useful. So, come on in, let's get started. Let's take a quick note on the key terms or the terminology that we'll be using in this particular session. So I'm going to introduce you to um, an organization called IETF, which is Internet Engineering Task Force. And what they do is they're a global organization and they're focused on developing internet standards, particularly those involving the Internet Protocol Suite, that is the TCP/IP. And the main output from this organization is something known as RFC, which you'll hear a lot. And that's called Request for Comments, which is essentially a formal document which outlines the protocols and internet standards such as HTTP. They have hundreds and thousands of documents which detail out a bunch of stuff. So they have multiple RFCs, and they keep updating those from time to time. So this particular RFC that we are looking at is RFC 9110, and this was published like just a couple of years back, right, June 2022. So they keep updating this, and they have the names of people who have contributed to it, and these are like public standards. Based on this information, protocols work, applications are built. It's very important to know the the details of these standards because this gives you the internal view of how things work the way they work. So with that out of the way, let's get started and focus on what is HTTP and learn all about the HTTP semantics. I've taken this paragraph from here, and the same paragraph you'll find here. What it says is we'll go through it, and then I'll tell you how to interpret this. This is quite a big paragraph, says a lot of things, and it can be pretty tricky for if you don't have a tech background, or if you haven't uh, read communications, networking, etc., to kind of make sense of it. So let me unpack this for you. So there are a few keywords in this whole paragraph that we need to be aware of, and that's where we'll get started. So let's highlight them. So the first thing to kind of pay attention to here, the first keyword is resource. HTTP provides a uniform interface for interacting with a resource. The second is, like, how does it do that? How does HTTP let you interact with a resource? By sending messages. So the next one to pay attention to is messages. And what type of messages are there? There are basically two types. One is a request and the other is a response, right? And these messages are exchanged between whom? These messages are exchanged between a client and a server. So what you have here is a client and you have a server. And both these client and server, they exchange these messages, interpret those messages, and then based on what is there in these messages, decide what to do or what not to do. One of the important things that is mentioned here is something called um, when the server sends a response, that response comprises of, among other things, status code and the content received. So these are some of the keywords to focus on, and I'll explain each one of them and how they interact in a simplified manner. So what we've got here is, let's say, a client. So this is a client, and there is, on the same lines, a server somewhere sitting here. Excuse my handwriting. And this server is typically managing what we known as a resource. So let's let this be a resource here. So this is a resource, and this resource could be anything. It could be an image, it could be a video, it could be a document, or really any data, any piece of data that this server is managing. Now this client is going to the client decides or knows which resource it wants to access, and we'll see in the as we go ahead in this session how the client knows it, and accordingly it constructs what is known as a request and sends it to the server. So here is the client sending a request to the server, and then the server that is listening for these requests, it interprets this request. It looks at things like the, for example, the header. It looks at things like the URL, right, of the request and many other parameters, and it decides what resource the client wants to access and what operation does the client want to perform on that resource. Does it simply want to view the resource, or does it want to change that particular resource? And accordingly, it performs that operation and sends back to the client what we know as a response. And this response, among other things, as we have seen above, has two things. The important things are the status code, and the other one is the content, which is usually in the body. So, based on these status codes and the content, the client decides what to do with this response. Should it show the response to the end user, or should it interpret it as an error message and accordingly inform the user that some error has occurred? Right. So that is decided by the status codes and what is there, and then what to show the user is there in the content. So this is how, at a very fundamental level, the HTTP communication happens between a client and the server. And a client could be any HTTP client. For example, in this case, it could be a browser. So this could be a browser that is being used to access a web page. And this is what this particular definition, the RFC that we just seen, this is what it is trying to convey. It's pretty simple. All right, let me talk a little bit about the resource itself and what the RFC says about it. So the RFC document says that the target of an HTTP request is called a resource. That's how they kind of define a resource. And the fact that HTTP does not limit the nature of the resource. It could be anything like we have seen before. It could be a image, it could be a video, document, any piece of data, anything that is addressable. It is essentially just an interface that might be used to interact with the resources. And that's what HTTP protocol is. And as we have seen before, that most resources are identified by a uniform resource identifier or a URI. And that is important. We'll see in a little bit of detail about the URI. But before we get there, one design goal of HTTP is to separate resource identification from request semantics, which is made possible by vesting the request semantics in the request method and a few request modifying header fields. So this might sound a little complicated, but it isn't really. Essentially, what this document is trying to tell you is that any resource is identified by an address, and that address is referred to as a uniform resource identifier. And also, what HTTP kind of achieves is that it separates the identification of the resource, which it is doing through the URI, from the request semantics, right? And how it does that is by making use of specific methods for specific operations. So there is a specific method that is used for fetching information. There is a specific method that is used for by HTTP as part of the request semantics to create an instance of a resource. And there are specific request methods to update a resource and to delete a resource and so on. And that is how it achieves this separation. So let's now quickly see what a URI kind of looks like. And sure enough, there is another RFC for that. We'll not go into the uh, very detailed deep dive into what URI is, but I'm going to kind of call out the main characteristics here. So for example, this is an example of what a URI kind of looks like, right? And it has certain parts that you should be aware of. So let's copy this here. Right, let's select this here. What you see here is typically known as a scheme, which is in this case foo. This is followed by something known as authority, or you can basically say it as a host name or a host, followed by a port, and then there is a path. Uh, the path can have other parameters as well. And when you encounter a question mark in the path, that basically signifies a query parameter. So this is how a query parameter starts, and then the query can have even a fragment. Anything followed by a hash is basically a fragment. So this is what the components of uh, URI looks like. Um, let's take a closer look at it in our context. So let's say we have this URI here. It basically represents an image. It's a publicly accessible URI. You can browse it. So it's basically a location. So you can call it a URL, because in this case, this this particular address that you see on the browser, this not only represents the resource, it it not only identifies a resource, it also serves as a location of the resource. Now, let's say if we had a URL like this, what it would mean essentially. Um, so this part here, right? This would represent something that is known as the scheme, right? So this is HTTP or HTTPS, which is secure HTTP. This part here is your host. And in some cases, in this particular case, there is no in this particular case there is no port associated with it, because this particular host is listening at the default port, which is 80. So it is as good as not represent, there's no need to add that port here as part of this URL. But if you're using another port, then the host name would be followed by a port. So this would be the port here. This path here is really the path. Like, this whole thing represents the path of the URI. And after the question mark here, which is this, This part is your query or query string. So essentially, what we have here, photos, this is essentially the resource. And this resource is identified by this whole combination of a scheme, a host, a port, the path, and the query. And that becomes the address of this resource. So this whole thing is the address of this resource. And that is what essentially you mean by the URI. So you have a uniform resource identifier. And in this particular case, because this is a URI, this is actually a live URL, um, this URI is also representing the location of that particular resource, which in this case is a photograph. And therefore, this is called a URL, that is a uniform resource locator. So we had learned that one of the design goals of HTTP is to separate the resource identification from the request semantics. And how it does that is through the use of request methods. So let's see what request methods are and how to go about it. And this RFC document kind of explains that. There are basically a few methods that you should be aware of when you are dealing with HTTP, and especially once you start building APIs, especially REST APIs. Um, there are a bunch of such methods, but the methods which are essentially most important or fundamental to HTTP operations are at least these four. First is the get, and the get method basically um, requests the transfer of a current selected representation of a target resource. So this is a very complex way of saying that the get methods basically returns or queries a resource for its most recent state, or whatever is the current state of it. If in the last example we have seen the example of a picture, right? The photo is a resource, and when we make a get request to it, we essentially get a response of the current state of that picture. That exactly is the picture that is available at that point in time when we make the request. Um, the successful response of a get operation is associated with a 200 response code. So this is something very important, right? So if we have to kind of remember it, we can basically think of it as let's say request methods. Right? And the one that we are looking right now is get. And the get is, if it is successful, it returns a 200 status code. And I'll show you where you can see these status codes actually. So this is um, pretty much what you need to know about the get method. It is basically used to query a resource. So the purpose of the get method is to query a particular resource, right? And that is essentially enough to kind of keep in mind. If you're a product manager, who's trying to sort of build APIs or want to learn more about HTTP, that kind of audience, this is kind of sufficient for you to know. The next one is known as a post. So the post method requests that the target resource process the representation enclosed in the request according to the resource's own specific semantics. For example, post is used for the following functions: providing a block of data such as fields enter into an HTML form for a data handling process, posting a message to a bulletin board, news group, mailing list, etc., creating a new resource that has yet to be identified by the origin server, and appending data to the resource's existing representations. So this is very important to understand. And then if one or more resources have been created on the origin server as a result of successfully processing the post request, the origin server should send a 201 created response containing the location header field that provides the identifier of the primary resource created and a representation that describes the status of the request while referring to the new resource. So this is a lot of information to process, and it can get pretty complex, but it is really very simple to understand. So when we talk about a post request, let me pick another color here. So we are, so this is post. So post, when it is successful, it is associated with a status code of 201. But apart from the status code of 201, it also returns something else. It returns a header called location. And it is basically used for creating a new instance of the resource. So this is the post method is associated with a create operation. When you are creating a new photo, you're submitting a new record to a customer feedback form, right? So a new record is getting created, a new instance of the resource is getting created. That is what the post method achieves. So this is what the post method is all about. The next method to kind of pay attention to is called the put. And the put method requests that the state of the target resource be created or replaced with the state identified by the representation enclosed in the request message. A successful put of a given representation would suggest that a subsequent get on the same target resource will result in an equivalent representation being sent in 200 OK response. Yeah, and same thing here. If the target resource does not have the current implementation and the put successfully creates one, then the origin server must inform the user agent by sending a 201 created response. If the target resource does not have the current representation and that representation is successfully modified in accordance with the state of the enclosed representation, then the origin server must send either a 20 OK, 200 OK, or a 204 no content response to indicate successful completion of a request. So these are essentially the semantics that govern how the put operation works. So let me simplify that for you. And before I do that, there is one more thing which is associated with the post, and that is known as the body, or you can say the data that you want to be created. So that is also a part of the request object here, right? Along with this method post and then the rest of the things. So similarly, you have the put here, which behaves in a more or less similar fashion, but there is a subtle difference here. So let's take a put. This also returns either a 200 status code, or it might return 201 plus a location header, right? And this is used to update the resource with the information that is there in the body of the request. So the same thing here. So this will update or replace the older value which is there of the resource with what you are sending here. So whatever you are sending here for an existing resource, it is going to update it. That means it is going to replace it and then give you a 200 response. In case this resource doesn't exist and you perform a put operation on it, what it can also do is it might create the resource and then return a 201 status code to you along with the location header, which will give you the location or the URL from where you can do a get operation, right? So that is how it works. So the last one is the delete operation. The delete method requests that the origin server remove the association between the target resource and its current functionality. In effect, this method is similar to the rm command in Unix, or the same command in DOS or whatever system you use. It's essentially deleting the resource, and I don't think it returns any message. Yeah, I mean, it returns a status code. If it is successful, it should basically send any one of these three. 202, which is accepted, which means that the action will likely succeed, but it may not yet have been enacted. A 204, no content status code if the action has been enacted and no further information is to be supplied. And a 200 OK if the action has been enacted and the response message includes a representation describing the status. So this is really simple to understand. Let's break it down here. This is let's this is delete, right? So it will have some sort of an identifier for the resource, right, to be deleted. It can return 202, right, which basically tells you that the delete operation has been successful, but it has been accepted, but it is not yet enacted. So this is the server has accepted your delete request on the resource, or it could return you 20, right? So this is usually the case with delete. That simply means that you know um, the request the resource has been the particular instance of the resource has been deleted, or it can give you 200 back, which is rare, along with some data which will tell you, which you might want to show to the client or something like that. And the purpose of this is to remove the resource. The purpose is removal of the resource, right? So this is as good as deleting a folder or deleting a file from your file system, whichever file system you might be using. So these are the 4 important request methods that HTTP provides, which are basically used for which provide you the request semantics, and are useful for performing operations on the resource. Okay, so let's recap what we have learned so far. And this diagram captures it pretty well. So for HTTP, what you have is a client which communicates with the server. The server manages the resource. The resource is identified by a URI or a URL, right? The client knows the address of this resource. If it doesn't know the address or the URL of this resource, it will not be able to make any request to the server to get this resource. So it makes the get request, and the purpose is to retrieve data. The client gets a response back with typically a status of 200 and some headers, right? And it sends the body in this request. The next action is post. The purpose is to create a new resource, right? And in the response, it typically gets 201 with a location header, etc., uh, and the like. The next, you have a put request, which is what the client can make. The purpose is to update the existing response, and you would get appropriate response back. And finally, what you have is a delete request, where the client can make a delete request where the objective is to delete the resource. Apart from that, there can be other kinds of status codes and responses as well. For example, 404, when the resource doesn't exist or is not found, or 500 if there is some internal server error, the server encounters some error and cannot process the request. So these are the error codes, status codes that are also supported by HTTP. So that kind of summarizes our learning so far, what HTTP is and how the HTTP semantics work for a client and server communication to take place. I hope you enjoyed this session and it gave you the clarity that you were looking for as far as this particular topic is concerned. Thank you. Until next time, have a good day.